Okay, it says we're live. So, welcome, Lindsey. Thanks so much for being here.
Thanks for having me.
Yeah, of course. So, everyone in the chat, just so you know, Lindsey here is a materials engineer officially because she just finished her degree at Cornell. So, did you just finish your bachelor's or your master's?
My master's, my MS. So I also did my bachelor's at Cornell, so a
Okay,
lot of time there.
nice. So you spend a lot of time there. So I mean, why materials engineering? Like, okay, well, yeah, let me back up. So can you explain to me the question that I'm sure everyone wants to know is like, what is materials engineering and how is it separated from something like civil engineering? Because I feel like a lot of the time, maybe sometimes people think, oh, like materials is in sort of every engineering, and why do we need it to be like separated? That was a
That's a
lot.
really good way of phrasing it. No, so to start out, materials engineering is like very simply put, just engineering materials. But I'll break that down. Basically, like any material that we're touching nowadays has probably been worked with by some sort of materials engineer. And the reason is that we need to make metals for bridges stronger. So even though like planes, for example, are made out of aluminum, aluminum, as you probably know, is actually not very strong on its
Mm-hmm.
own. So we alloy it, and we do research to find the ways to make an airplane still very light, but also strong because it's an airplane and people's lives are at stake.
Yeah.
So it's like one type, but this tweaking at atoms and tweaking at the molecular structure bleeds into like all materials. So that goes down to polymers. Like think about sticky tack, for example. Someone had to invent that, or post-it notes, the adhesion layer on the back that like won't rip off your wall if you put it there, but
Yeah.
it'll stay for a long period of time. And then the part that I'm most interested in is electronics, and that's just everything that's in your cell phone. I mean, that's been completely during the human technology exploration has been heavily researched how we can store and process information on the materials level. So that's a really broad overview. And what's really interesting about that is its ability to go into other fields. So you were mentioning like civil, for example. It's really important that you have someone who understands the properties of materials when they're being applied,
Mm-hmm.
like concrete in mechanical projects or metals in these kind of mechanical projects. It's really important that you understand the limits and what's required of it. And then in technology, we're always trying to improve on those things. So how can we make something equally as strong but thinner? That comes down to being a materials challenge. So that bleeds into basically like a few categories. It's mechanical, it's polymers, it's electronic, it's bio. That's a really big component of it as well. Thinking about ways that we can make biological tools like for surgery or implants, making those improved.
Okay,
So
yeah, yeah. So I
a
can
lot of
imagine
information.
there's a no. That's really good. I mean, now I'm thinking about yeah, all the different applications because also in biomedical engineering, you definitely want, I guess, a leg that or like some part implant in your leg that's functional but also non-toxic or,
Yeah.
and that's definitely a materials challenge. And then also now I'm thinking about in gas turbines, like where I work right now in an aircraft. We have the challenge of like extremely high pressures and temperatures, and if you just use like super strong materials, then you're losing on cost, and also like in fabricating the materials, sometimes it's not as easy to fabricate. So I'm assuming also in all of these challenges, you have to like, yeah, consider like the cost of the material and the extraction and the, I don't know, maybe I'm assuming recycling too and disposal.
Yeah. So a lot of it does come down to processing. Ultimately, like if you process things at high temperature versus low temperature, you're going to get different properties, which is one of the things you mentioned. Um, and recyclability. I mean, people really want to step away from plastics and stuff because right now we don't. They're not. Even though they're recyclable, they're not biodegradable, which means that what a lot of people don't understand about plastics is that you start with a plastic number one, and that can be recycled into plastic number two,
Mm-hmm.
and so on. And as most people know, not every place even recycles them past 3 or 4 or so. So you're definitely getting to a place where you're left over with something that's degraded in its value. But it's good that you can reuse what's already been made, but ultimately it's still going to end up in the ground. There's still going to be a final. So that's one of the big challenges as well, is what are we going to do with these materials that we're making?
Yeah.
In other fields, like in metallurgy, steel, for example, is very recyclable. So you can take those out of bridges and build new bridges, which is wonderful. But in the polymers area, there's definitely more struggle. And yeah, so it's a big bit.
Okay, yeah. So now then, as you were speaking, I was thinking, what about coatings? Are coatings also a materials challenge in terms of like, if you're making, I don't know, like you want something to be dust resistant and like the inside. Now I'm just thinking in terms of like an engine, like would that be coatings? Be
the films that you see on the surface are definitely also materials. So materials like comes in all sizes kind of thing. Like we talk about bulk materials, and then we talk about film. And that's an entire category where you can take like many courses in a university just on the films alone and how they're made to have those properties.
Okay. So would you be able to talk about the different disciplines of materials engineering and then also what your discipline is?
Sure. Yeah. So I guess I touched on it a little bit, maybe better if I specified. So it often gets broken up into, okay, so there's 4 classes of materials. I'll just start there.
Okay.
4 classes of materials, which is what you would learn in your like intro to material science course, would be first metals, which is pretty intuitive. I think most people understand what that is. Polymers, which includes plastics, which is also, people understand. Ceramics, which actually a lot of people don't understand. It's not just the stuff you make in pottery class.
Okay.
It's actually oxide materials. And then the last one is composites, which is basically just a combination of the 3 other ones. And so all materials on the world will fall into one of these. Most of nature is actually composites. I mean, like bones are composites, for example. So those are the 4 categories. And then from them, you end up looking at the different properties, and most people would break that off into 2 groups, like electronic and mechanical. Mm-hmm. And from there, you can kind of pick a path from there, I would say most people are able to say that they're on either the mechanical or the electrical. I should say electrical, magnetic, and optics side.
Okay. And your stream? What is your stream?
My stream is ceramics, electronic. Little known fact is that ceramics are basically what's in your phone. So, I mean, a lot of it is obviously metal because it's electronics and that's how you think. But semiconductors are often actually part of the category of ceramics. Not always, but sometimes. Yeah. So that's actually what I work with, because I do work with oxides. And they're oxide semiconductors. So it's pretty cool.
Okay, so before we get into like
that's
your research, before we get into that, which is going to be really exciting. So you did your bachelor's and your master's both at Cornell. Mm-hmm. And is materials engineering, when you were going into it, you're going into your bachelor's, was it always something that you were going to do? Like, when did you decide you wanted to study it? Did you decide you want to study it, or did you just stumble into it? What was your path?
Yeah, I get asked this a lot because it's not such a typical path. So people think that there must be some grand story, like I met some physicist who told me to do this. But it was kind of a funny thing. Like, I went after high school, I realized I enjoyed chemistry, but I did not want to be a chemical engineer. I was like, I do not appreciate chemistry to that high degree that I want to only be taking chemistry classes. And I liked physics, but again, I didn't want to be applied physics because I didn't feel like in love with physics. I didn't want to be, calling myself a physicist. So I said, okay, I'll go into the engineering track. And someone brought up to me this like really interesting concept that, if you change the atoms in a structure of a crystal, you're going to get different properties. And that like blew my mind. It like ignited a spark. So they were like, that's called material science. So knowing just that little fact, I was like, okay, I'll keep that in the back of my mind. And I got to college and people started asking me, oh, you're an engineer, what type? And I just started saying it. Like, I didn't know much, but I said, oh, I'm a materials engineer. And they were like, oh, that's so cool. And I said it enough times that eventually it just kind of became truth. And I took the classes. I applied to be part of that major. That's basically what happened. Which is really funny because I'm really happy with it, but it was not really a conscious decision. I think it was like the best combination of the fields that I wanted. Because I think a lot of people think that it's very similar to chemistry, but I would argue it's far more similar to a traditional physics. Mm-hmm. So I really appreciated that, and I appreciated how relevant it felt that you could look at any material and you could define its properties by some molecular structure that we can't even see. So that really kind of inspired me.
It seems like whoever that was that told you, like, you can change a molecule and get different properties in a crystal. Like, have you thanked that person?
It was like a random. That's the thing is, I wish that was like you know, an uncle or like someone who like is important to me. But it was just. I went to like a woman in engineering day and they had little booths set up and like little demonstrations and it was like a 2-second conversation. So I couldn't even tell you that person's name or what they look like. Like I just remember that it happened, which is crazy because it changed my life, but maybe I would have fallen into it anyways. Who knows?
Yeah, no, I mean, really almost the same thing happened to me. I was on an airplane and the guy sitting like I always had this thought in the back of my head, oh, I think I want to be an aerospace engineer, but I never had the confidence until I sat next to a guy on a plane who I can't tell you his name. I don't know what he looks like. I think he was studying in Germany doing his PhD, and I told him, he's like, oh, what do you want to do? I was like, I always thought I wanted to be like aerospace engineer, but I don't think I'm good enough or whatever. And he was just like, yeah, it's super easy. I'm an aerospace engineer. You should do it. And I was like, okay, yeah, this stranger says I can, so, but he's an engineer, so clearly he knows everything.
It's so funny because it's so true. I feel like there's just like this time in our lives when we're so impressionable, and if you say that to me, like I will have to believe it.
Yeah, no, exactly. And I was like, well, he's a rocket scientist, so clearly he knows what he's talking about. And clearly after talking to me for like 3 hours, he knows everything about me and knows my intelligence.
Yeah, 100%. That was like your destiny just after.
And yours too with the person at the booth.
Yeah, it was crazy.
So why did you decide then after your, so you did a 4-year bachelor because it's in the States, I'm assuming, yeah. So why after your bachelor's did you decide to do a master's?
Yeah, that's a really non-straightforward answer, unfortunately. I, for a very long time, wanted to get a PhD, and that was, just fine. Mm-hmm. Like, it was the path that I was on because I was doing research, and a lot of people who do research as undergrads, that's their ultimate goal. And I was speaking to a grad student, and I, had known her for, those a really long time at that point, almost 4 years. And I've discovered she was leaving the program, and she was in her 5th year. And I'm like, whoa, if you leave your program after 5 years, that means, you don't see that the end is near. Whoa. And it really, hit me. I was like, yo, you could be here a really long time. And I don't think that I was, scared necessarily. I don't think I was not willing to put in those years. But it kind of made me take a step back and be like, okay, is this actually what I want? Because this is not a decision you make lightly. You have to be in it. Yeah. So it wasn't so much intimidated by the 7 years, but it made me realize, okay, this is a decision I need to spend more time on. I can't just come into it because I'm doing research and because that's the track I'm on. I need to actually process this. So I was processing that for a while, and then I thought maybe I'll take a year off, do something else for a year, and then I'll come back to it, trying to figure it out. And it just so happens that there was a specialized program that would let me do my master's faster without taking as many classes. And so all I had to do was apply. And because the research that I was doing as an undergrad was basically at the level of a grad student and I was about to publish my paper and everything was going really well, it made a good story for me as an applicant. And in that program, I would only have to take 2 classes and I would get done in 2 semesters. And as long as I could publish a paper at the end of it, they would be happy. I'm like, if I did a master's anywhere else, I would probably have to retake a lot of the same classes.
Mm.
And they're just saying I can take any 2 classes, which is awesome because very infrequently in university do they say take whatever you want. So I was like, okay. I think about it. I was like, I don't really want to stay. I think I need to move on. It'd be better for me to move on. And then I thought about it and I slept on it and said, this is a good opportunity. So I applied for it, and then I also applied for a scholarship, and I got the scholarship, and I got into the program. So I was like, okay,
Yeah.
Got to go all in. And I'm very happy I did because I realized that the job that I have now and I'm about to start, I wouldn't have gotten without the master's. Like, that was my foot into the door. And there's a lot of benefits that have come out of it, like having extra papers on top of my bachelor work, and having an extra year of experience doing research and networking with the people that I was able to meet this year. It was really important. So I definitely don't regret the decision, but I definitely felt like I wasn't making the decision. It was kind of a twist my arm situation. I wasn't 100% sure about it, but I'm 100% sure about it now.
That's like really great when you come out of it and you're like, okay, I'm happy. It all, like, I made the right decision. I feel like if I would have gotten a scholarship, it would have sort of been to me like, maybe this is a sign. Like, that's the point when you're like, oh, well, now I'm just turning down money.
Yeah. And it was a really good scholarship too. It came with a stipend, like, for living expenses. So like, it was definitely not a situation where I could turn it down. So, okay, I'll do this.
So you did research in your undergrad then, and you had a paper published from your undergrad.
Yeah, it wasn't in like a super major journal, but it did get published. And so yeah, I'm published, which was really exciting, especially as an undergrad for sure.
Do you think that helped you or like gave you an advantage into getting into this program? Or
Yeah, I think if I hadn't been able to actually publish it, it would have still been an advantage to have the experience of, like, at least having a paper or a completed project to show to them. Because I think that one of the things that they like to see is that you're able to overcome challenges. And if you just have research experience, it doesn't necessarily say to the viewer, like, this person overcame things, because research experience could just mean
you were mopping up the lab, like
mopping up the lab. Exactly. So it kind of was able to prove, okay, this person's been able to, like, see challenges and overcome them and whatnot. And I don't think that publishing was necessarily the part that showed that, but just being able to, like, write an abstract about the work and write something about it showed that I was, like, really involved in it.
Yeah.
Mopping up the lab.
Yeah, I just want to clarify for those watching, because a lot of the times when viewers hear something like that, they get really stressed out and then they think, okay, now I need to publish a paper, like, in order to do that. So I just wanted to point out that when I did my undergrad research, for those listening, most people already know, but, like, when I did my undergrad research, I had a paper that, like, I had written, but it wasn't published. Like, it was submitted to the journal. So when I went to apply to universities, they saw this paper has been submitted, but they never saw the outcome of that, and they didn't really care in the end. So I think even if it wasn't accepted, like you said, the most important thing was that they just want to know that, like, you had, like, a project with substance, like you were actually producing results and overcoming challenges, like you said.
Yeah,
so I think
definitely.
I
100% agree. Yeah, just not mopping the floor.
Yeah, no.
Hopefully come over that hurdle, yeah.
So what about for the job you have now? Do you, like you said, that for sure you wouldn't have been able to get it with your experience that you've gained from this master's degree. Do you think that, and then you also said from your master's degree it was necessary that you publish a paper. Do you think that goes hand in hand? Like, do you think that this company was sort of looking for that experience in publishing a paper, or do you just think, again, it was more of you produced results and, like, sort of proving, I guess, that you're a worker and a scientist?
I think there's a lot of levels to that
Okay.
question. I'll start with saying I think I probably could have still worked for the same company without a master's degree. I just wouldn't have had the position that I was offered. Because in a lot of tech companies, there's just like different, you could be like a technician versus an engineer versus, and there's just like a range of different positions that have different degree requirements. So I think that's more of what I meant. But then in terms of actually getting that job, I definitely think that they wanted to see me overcoming challenges. I don't think anyone at my interview had actually like read my paper.
Okay.
But I did have to give a talk. At every place I interviewed, I like brought slides showing my work and stuff. Because that's in industry, you're just, overcoming challenges having to do with your field. So proving that you've already been able to do that. I think.
I like those interviews. I had to do the same one for my current job now.
Yeah.
It's really, I don't know, I feel a lot more confident when I'm the one in the room knowing what I'm talking about. And
Yes.
like it sort of makes me feel like I'm the smartest person in the room. And these people are asking me questions, and like because it's my work, I'm able to answer it. But I mean, again, if you do the work, you're able to do it. And if you're just mopping the floor, you're not gonna have any slides to present.
Yeah, no, it's totally true. Like they could ask me questions and it was like, of course I know the nuances of this. This is like I was doing this every day until 3 a.m. Like of course I know the nuances of like, all these little details, which is great, and that's the intention. But I will say, okay, we've been making fun of the person who mops the floor. When I first started research, like I had the task of like grinding crystals. Literally, I mean, it's kind of high tech, but at the end of the day, it was glorified grinding, like mechanically grinding crystals, which is like pretty boring. It doesn't take a genius to do. And like I got very good at it, and then they noticed, and then they gave me more and more responsibilities. So I will say that if any of the viewers out there are like, oh, I do the really grunt work in the lab, I don't do anything important, like keep doing it and be the best person at doing it, and you will be noticed. And if they don't notice you make them notice you. Because I think a lot of people are willing to give opportunities to people who are hardworking.
Yeah, that's for sure. I see that a lot too, especially with my professors. So I just wanted to point out someone here. Naomi Burgos says that the stream is really motivating. And then someone else, I think it's Steve. So someone else was just asking, and I just wanted to reiterate that Lindsey is from the US, and she's just finished her master's in materials engineering at Cornell, and now she's moving to Portland for a new job. So my next question wanted to be about your research. I wanted to know more, if you're able to talk about it, like I guess not so in detail because I'm not a materials engineer, and a lot of people watching aren't materials engineers, or some of them are high school students. But like, what is your research and what is its purpose? Like, why is the problem that you're trying to overcome important?
Mm-hmm. So my research, we have a technique where we grow, okay, and just quotes that people get very confused. There's no biology happening here. We grow thin films, and we use a method that's incredibly precise. So we have a vacuum chamber, and in that chamber we generate a flux of atoms that are very pure. So you could use copper, for example, very pure copper in a crucible. We generate a flux of copper, and those atoms, because it's in vacuum, they go to the surface of a substrate, which is basically the target, and they can deposit a film. So since I work with oxides, we'll fill our chamber with very, very pure oxygen to do that. So you could make like a copper oxide, for example. And there's tons of different elemental sources that we use to do that. And what's amazing about this method is anything that you can imagine, you can probably figure out a way to build using the right resource and doing the research ahead of time about, what kind of temperature would be good, what kind of pressure would be good. You can pretty much make any material that you can read about. So it's pretty cool.
Okay, wow.
Think of it as like a 3D printer, but like on the atom level. Instead of 3D printing like one piece of polymer at a time, it's like an atom at a time.
Wow. That's pretty cool. And how long does it take to make a
So this is always actually a dilemma. There's a funny thing, like if you make a fast flux of atoms, then it'll grow faster. But if you make a slow flux, it'll grow slower. But as with most things, like if you're trying to build and you take your time, it'll probably end up being higher quality. So there's definitely like an optimization of you want it to be fast so you're not waiting all day, but also like slow enough that it looks good. So these growths can take anywhere from 30 minutes to a few hours to get just on the order of like 10 nanometers, which is really, really thin. We're growing like, we can grow things as small as like your pinky nail grows in a second.
Okay. So
really, really, really small.
is it more to, like, I guess, make the material, or is it more of a way to not cast, but I guess like a way of forming or casting or like of molding material to different shapes?
Yeah, so they're basically just like flat layers.
Okay.
And I missed this part, but earlier when I forgot to say, the purpose is you can test properties of these thin films. And thin films actually have different properties than their bulk material. So we are able to test those, and most of the applications are for different kinds of electronic devices, whether that uses magnetism, electronics, whatnot. So superconductors is a very hot topic right now. That's something that we can do because you can still test the properties of these really thin films in a macroscopic way. Mm-hmm. So most of the applications would be for different kinds of devices.
Okay. So I had some more questions, but I just needed to check my thing because I want to answer the questions that some people have asked me to ask you.
Okay.
So I guess you already touched on this a little bit, but some people wanted to know, like, what kind of the sciences are involved in material science? And I guess you already touched on, like, physics and chemistry. Mm-hmm. What about biology?
So I think that ends up being an option. There is an option that you can go into a biology track and study biomaterials, mm-hmm. but those classes are basically never the core requirements. And in those classes, you would study like how the body reacts to a foreign substance and how you can make that foreign material more like the body so that the body accepts it, and how you test them on animals and things like that. But that's definitely not a requirement of the curriculum. But I would say, so you have to take general chemistry with all the other engineers, and then we have a materials chemistry class. And besides that, you have 3 physics classes, and then, just the core material science. And in the end, like the thing that's probably most relevant is like a good understanding of how math works, okay. Because a lot of it does come down to, equations that are more often studied in this field, things like that, and understanding data and understanding how to work equations to determine different things.
Okay, and can I ask you, do you do a lot of tensor algebra?
Yeah, we use like Mathematica, which definitely helps.
Okay.
It's not in all of the classes, but it definitely comes around tensor algebra. Yeah.
Okay. Yeah, I took one deformable mechanics class. Oh my goodness, it was such heavy. Like, we deal with heavy math, but not in 3D. Like, in physical, yeah. Like in material, like. I can't explain it. Like, in fluid flows, like in equations, Navier-Stokes. But having to deal with, like, tensors was just, it was racking our brains.
It's definitely a lot because you're dealing with, okay, what direction is this going to move in 3 dimensions? But then also, like, what direction is it acted on in 3 dimensions? And it's just craziness. I wouldn't say that it comes up that often in my research, although I'm sure there's different types of research where it does. Uh-huh. But I think the understanding of it helps you to understand that things aren't isotropic. Isotropic meaning like things are the same in all directions. So learning tensor math basically like is a wake-up call that you can't treat materials like they're going to be the same in all directions.
Mm-hmm. So you touched on Mathematica a little bit, and Francisco, I hope I said your name right, asks if you use code a lot, like if you use a lot of programming in your degree.
Yeah, so I think in coursework, it's kind of up to you. I definitely had classes where Mathematica was the chosen language that you would use, and like TAs wouldn't really be able to help you if you didn't use Mathematica. It was pretty necessary when you're dealing with tensors of really high orders, or high ranks, I guess is the appropriate term. So Mathematica for that. I've also used MATLAB in classes because if you're just dealing with data, it can make things a lot easier. I think one of the things that's interesting about my field is, technically speaking, you don't need to know code, but your life will be a lot easier
Yeah.
if you do, which is really funny because there will be people who resist, and at some point they're like, I can't do this anymore, and they will switch to code.
Yeah, I mean, I have friends that have gone through our entire degree not learning to program, and then they go get an MBA after engineering. Like, you can get through it, but I feel for me, it was definitely an asset.
It was an asset, but the other interesting thing is my level of code is not even that high. Like, I didn't need a high level of code in order to be able to do those things. It was like very simple manipulations of things, but then it saves me so much time in actually, if I was to do it otherwise.
Yeah,
so
no,
it's worth it.
I just wanted to look at some of the questions some people asked. Someone wanted to know, I don't know if you can answer this because it's very specific. But Isha Bhat, I interviewed her. She was she was the first person I interviewed this month. But she wants to know if you worked on any battery fabrication.
I didn't.
Okay.
Yeah, sorry. That's kind of, yeah. I do know people who do. It's very popular in my field, but I actually haven't.
Okay, no, that's fine. I just wanted to ask because she wanted to know. Okay, and then someone else. There was another good question, I think. I don't remember. I just have to go through. Sorry. Someone wanted to know, this is sort of like a fun question. If you weren't going to go into materials engineering, I guess, what field of engineering would you have chosen? Or maybe even not even engineering. Would you have been a technician?
I think I would have still been an engineer.
Okay.
Maybe. I think I wouldn't have chosen it at the time that I was deciding, but I think in hindsight, if you had to eliminate this as an option, I probably would have gone into applied physics.
Okay.
Or electrical engineering. But I definitely wouldn't have chosen either of those as a freshman, I don't think.
As
so interesting.
You wouldn't have chosen like mechanical or chemical or any of those other?
I don't think so. I think, yeah, as a freshman, if materials didn't exist, I might have said chemical. But in hindsight, like my second favorites would definitely be applied physics or electrical.
Okay. Yeah, electrical scares me. It's definitely not my forte, but yeah, it's definitely, I respect people that go into electrical engineering a lot. Yeah. And I wanted to know too, I had a question, but I forgot. I'm so, like, I have the worst memory. No. Okay, wait. No, I wanted to know, about the engineerists. So can you tell me and everyone watching what you're doing over on Instagram with the engineerists?
Sure.
Maybe you don't think you're doing something, but I think it's really cool. You're sharing your journey.
Thank you. No, so basically that was the objective was, I basically wanted to put a face to the woman engineer. I mean, there's a lot of faces. It's not just mine. But I felt like one of the things that's lacking is that we keep saying, oh, girls should do this, but kids are actually really funny. Like, they will follow a suit that they see. It's not that hard for them, but they have to be given like the opportunity to see themselves in that position.
For sure.
And I think it's really difficult if you're growing up and you've never seen someone like yourself doing something. Why would you think that it's even a possibility? And one of the things that's so crazy about this is it forms at such a young age. I mean, people do so many studies about, math scores and all these things. And it's so interesting. Like, women are just as good at these subjects, but when they're told that they shouldn't be or that it's less common to be, that's when their scores drop. So I think in that sense, like, there's definitely a perception aspect to this problem of why women aren't going into these fields. So I really wanted to kind of direct my attention towards like perception and what that's like. And I didn't want to, so to do that, I wanted to make an Instagram showing like, I think I'm relatively normal, a relatively normal girl, doing these fields. And it doesn't mean that I have to be like the smartest person ever. And I think that's one of a lot of women's fears is like, in order to go into a male dominated field, you would have to be the brightest person ever. And it's definitely, I'm not the smartest person in the universe, but I work hard and I take every day at a time, and that's kind of what you need to be an engineer. So I was hoping to just show that, and that maybe that by seeing me, a girl could picture herself in the same career.
Yeah, no, and I completely agree with you. I mean, that's why I started to do the interviews, because I wanted to do exactly that, just showcase particularly women in the engineering, in different, not even engineering, just like STEM fields, so that people are just, it's like a resource. It's there, it's on the internet, people can look at it, and then they'll be able to see, oh, okay, there's someone like me in this field that is exactly the field I want to go into. Yeah. And damn it. Oh, yeah, I remember now. So what, if someone wanted to become a materials engineer, what would be the one advice, like the best advice that you could give them / your younger self, like about becoming a materials engineer? I put you on the spot. You have to think of something really good to young Lindsey.
I don't know that. I don't know. Like, I struggled a lot. So I think if someone had told me, I mean, I struggled a lot with my coursework. Someone had told me, like, you'll get through it, I promise. Man, that would have been nice to hear. There was a lot of times that I didn't think that would be true. But yeah, I think if you keep working hard and like, if to do that, you need to take one last class and actually apply yourself, you should do that. But like, don't give up, because you have the capacity to get through it.
Mm-hmm. Yeah, no, I mean, I also see that a lot of myself. I would probably tell myself the same thing, because you do that one assignment that you think is impossible and you get through it, and then that is what keeps me going in the next assignment. I'm like I can't figure this out now, but I figured out that last problem, so maybe I'll be able to figure it out. I don't know.
Yeah, you just have to keep plugging away, keep talking to other people. Oh, that's a piece of advice I would give, is like, community is your friend. I like would not be anywhere without the people that I was shared my major with. Like, we all helped each other, and there's often this misconception that engineers just keep to themselves and like in a corner or like erasing away at their homework. I did so much work, and I learned so much from the people around me. I mean, it was my work, but they would bring me to they would help me to get to new places so that I could finish. So
yeah, that's the great thing about engineering, is like, I feel like we're all suffering together.
Yeah. Yeah.
So after exams, I just remember coming out of like midterms and looking at my friends and being like, and they would be like, and we would just laugh, because we were like, yeah, we're screwed. And then you just study together and laugh about it together and help each other through it. And I really like that camaraderie in engineering.
Totally.
Yeah, I hear.
Not more.
No.
I couldn't agree more. It's amazing. Yeah. It's the best.
So I guess in terms of like thinking about the future, I don't know. I don't think about the future a lot, but maybe you do. Do you, like, right now you're starting a real job. Do you think you want, I mean, I guess you don't know yet because you haven't started it yet, but do you think in the future you would like to stay at the way you see it now? Would you like to stay sort of in like the corporate world, like in the industry, or do you think eventually you'll go back to get a PhD? What do you think? Do you think about that at all?
Yeah, I do. I think I would like to stay. That's like what I think now, definitely. yeah,
Okay.
that's what I think right now.
Yeah. I also like to think that I want to stay in like the sciencey part of stuff, you know? Like
Mhm.
yeah. And then I had one more question, but I can't remember. Oh my goodness. Here, let me look at my. It's so hard in live streams because usually I can cut this stuff out, but in live streams I can't. And I'm like, "Oh, why do you have to be so awkward, Jess?" Like,
I don't think it's awkward. Don't worry.
okay, okay.
It's just like you had a full work day before this.
Oh, okay. And then last question is, I just read it and I already forgot it. Okay. Last question is, what is the coolest thing about materials engineering that you think? Like, is there something really cool like that you read recently in the news that's innovative about it, or is there something like just in general, like an overall like picture of the field that you really like about materials engineering? Um, yeah, so that's my question, I guess.
Okay. No, I'll think about it. I mean, there's like a couple different directions I could take that, I guess. Uh, I mean, it's really, for me, it's one of the really cool things is that transistors are going in the direction where there's now like a one atom transistor, um, which is crazy that things are working on that level. So I think like in terms of the future, there's so much to look forward to within this field of materials engineering because things like that are possible.
Mm-hmm.
In like a totally different direction, I'm just still fascinated by the fact that, for example, with like perovskite structures, you can have the same structure, like three different materials. Everything is the same except for like you change out one of the atoms for a different transition metal, and all of a sudden you have completely different properties. Like you could have one would be completely metallic, and the other one would be completely insulating. And that just always blows my mind. Like you're changing from one transition metal to another, and you're only changing of that crystal structure. You're only changing like a few of the atoms. You're only changing, 15% of the whole makeup, and everything else is the same. And it changes so drastically, and that's just I'll never really get over that.
Yeah. Yeah, I kind of, I
Hear it. I'm
guess,
like getting excited talking about.
I guess if you start talking about like changing one molecule in a crystal that changes like the properties of a crystal, it kind of starts sounding like witchcraft to me. I don't know. Maybe you
Yeah,
like to think of yourself as like playing with
kind of
witchcraft.
alchemy.
Um,
Yeah.
Before we go, I just want, because Martina asked this question a few times, but I know you said you don't work in coatings, but she wanted to know, can you talk a bit more about coatings? So can you suggest somewhere where she can go find that on her own? Because you said it's not your
I mean,
specialization.
about someone wanting to learn code.
No, coatings like
Oh,
on
coding.
materials. Yeah.
Oh. Um, I mean, I guess it depends on the application because there's a huge range of when people use it. So if you were to look up the application of it, let's say, I don't know, like paper cups that have a waxy coating, and you wanted to look up like waxy coating in paper cups, I'm sure you would eventually get to some journal articles that have that if you search it by the application.
Okay. And also, Martina, maybe take a course. Like, I don't think it hurts to, like you said, that you can take tons of courses in the subject. So,
Thin films would be like a broader term that you could
yeah.
definitely.
But at least, like, take it and see if you like it. I mean, that's definitely how I figured out what I wanted to do by taking a whole bunch of classes and figuring out what I didn't like.
Yeah, totally fair.
Yeah. So thanks so much, Lindsey, for talking to me. And everyone is super stoked that we got to talk. So, like, the live chat, you'll be able to see it back if you want later. But there are a lot of people watching. So, everyone, thank you so much for watching. We're approaching 45 minutes. I mean, we've already surpassed 45 minutes. So, we're going to go now. But if you want to find Lindsey, you can see below her tags. I'll also link her in the description so you can find her on Instagram. She shares everything about materials engineering there, so you can definitely check her out there. And once again, thank you so much for taking the time.
Thanks for having me. It was such a pleasure.
Okay. Thank you guys for watching. We'll see you another time.